Welcome to the video, the last video of Unit 10 for now, writing equations from a graph. Today we're going to understand again how h, and k affect the graph of a quadratic function relative to its parent function. And given a graph, we're going to write a quadratic equation in vertex form. That is the most important thing about today's video, is that we're going to do this given a graph, not an equation. So in the past videos, what we have been doing in the past is we have been graphing quadratic functions in standard form, intercept form, and vertex form when we were given the equation. So we started out given the equation, graph the parabola. So I could have given you 2 times x minus 1 squared plus 3, and you would know that the vertex is where? Where is the vertex of this graph? Well, the h value is 1. Remember, it's the opposite of what's inside, so it's not negative 1, it's positive 1. And the y value is 3. Now I would make a table, so all of a sudden I'd have 1, and then 1, 2, 3. There's my vertex. This is going to open up because a is positive. It's going to be steep. It's going to look something like this. I can use a table and get my parabola graphed. But today, what we're going to learn is how to write the equation given a picture. So now I'm going to start with the picture and get the graph, get the equation from the picture. So for example, write a quadratic function in vertex form for the parabola. So quadratic function in vertex form is a times x minus h squared plus k. Now, the h and k value come from the coordinates of the vertex. What are the coordinates of the vertex? 2, negative 3. I love doing these graphs because they're so easy. All I have to do is plug in the h and the k value. X minus, what's the h value? It's positive 2, so I'm going to put a positive 2 at the place of h. And then what's k? What's the y value of the vertex? Negative 3. So I'm going to put a plus negative 3 on the end. And now I can simplify. Y equals a times x minus 2 squared minus 3. Because plus negative 3 is the same thing as just minus 3. Now the last thing I need to do is find out what the a value is. I need to find out what is a. In order to find out what a value is, I need to plug in a point other than the vertex. I have to plug in this point, 3, negative 2. Negative 2 is the y value, 3 is the x value, and all I have to do now is just plug in those values for x and y into the equation and solve. So now I'm going to have negative 2 is equal to a, and what's 3 minus 2? That's 1 squared minus 3. Again, I did what's inside the parentheses first. PEMDAS is how I do this. Parentheses, exponents, multiply, divide, add, and subtract. So I did the parentheses first. Now I have to do the exponent. So I have negative 2 equals a times 1 minus 3. Now I have to do multiply, divide. So I take a times 1. Okay, a times 1 is 1 equals negative 2 minus 3. Sorry, just a. I forgot that in there. Let's scroll down a little bit more. Then I have to add 3 to both sides. A equals 1. So now my final answer, I plug the a back in. Y equals, a was 1 times x minus 2 squared plus, I'm sorry, not plus, minus 3. There you have it. It's just as easy as that. You plug in the vertex in for h and k, you plug in another point for x and y, and then you solve. Here's another example. All right, again, the instructions are write a quadratic function for the parabola shown. Well, y equals a times x minus h squared plus k. Now, what's interesting about this one is that we don't have the vertex labeled, okay? So we don't have that vertex. We can kind of guess, but it's not right on the lattice point. I'm not 100% confident of the coordinates of what this vertex would be. So maybe I can't use vertex form. Maybe I want to use a different form. What am I given in this graph? I have a point, negative 1, 2, but look at these ones. Those are special points on a parabola. It's where the parabola crosses the x-axis. Those are called x-intercepts, or roots, or zeros, or solutions. X-intercepts, right there. And so the intercept form of an equation is not a times x minus h squared plus k. It's a times x minus q and x minus p, or maybe the other way around, x minus p, x minus q, where q and p are the x-intercepts. So all I have to do now, instead of using the vertex, I'm going to use those x-intercept values and plug those in for q and for x. So x minus, what is the first x-intercept? It's at -2, right here. So every box is worth 1, so that's -2. So x minus of -2, and then x minus of +3. Now let's simplify again. Y equals a times x minus a -2 becomes +2, and x minus 3. So now I need to find out what that a value is, just like I did last time. And what did I do last time? I plugged in the other point that was given to me that was not the vertex. In this case, I can't use the same points I used for the intercepts. So I have to use the y value, and the y value is 2. The x value is -1. I have to use that twice for x. So y equals a times x plus 2 and x minus 3. Now the x and y values have been replaced with -1 and 2 respectively. So if 2 is a times what's -1 plus 2, that's 1. -1 minus 3 is -4. So then now I have 2 equals a times, and I multiply -4. Now I must divide by -4 to solve for a. So a is equal to -1/2. And so now I have enough information to write my equation. My equation then is y equals, I'm going to use blue to designate this as my final answer. Y equals -1/2 times x plus 2, x minus 3. Now, what form did it say? It didn't say any form. I could just leave it just like this. Now, if I want to write it in standard form, this is intercept form. Intercept form. To write it in standard form, all I would need to do is multiply the two binomials together and then multiply by a. So I have -1/2 and x times x, x squared, -3x, +2x, and the last one would be -6. So y equals -1/2. Let's combine the like terms in there. X squared minus x minus 6. And multiply by 1/2 on everything now. Distribute to all three terms. So y equals -1/2 x squared plus 1/2 x plus 3. And that's standard form. So I've reviewed two of the different forms we have. We have intercept form, which is in blue. That's from Unit 8. Standard form from Unit 9. And now vertex form for Unit 10. I need to find the vertex of this equation. To find the vertex of this equation, I can just find the middle and plug it into the equation for x. So the middle between -2 and +3 would be 0.5. If I plug in 1/2 into the equation for x, into either one of these, I can get the vertex. So if I do that, y equals, I'm going to plug it in the factored form, or intercept form. 1/2 plus 2, 1/2 minus 3. So I get -1/2 equals 2.5 times -2.5. So then I get -1/2 times -6.25. So I get +3.125. And if you're wondering how I'm getting these, it's just because I'm doing the math in my head. You could certainly use a calculator to help you out and find out what that y value was. So my vertex now is at 0.5, 3.125. Now let's practice writing in vertex form. So now I have the vertex, y equals a. What was a? It's still -1/2. Same thing as it was before. And so now I have x minus the y, or the x coordinate of the vertex, 0.5, squared, plus the k value of the vertex, which is 3.125. All right, so there we have all three forms side by side. We have vertex form on the bottom that I just did, with the vertex in it. The standard form up here after I multiplied it out, and then the factored form, or intercept form that I used before. So that's the big idea, is we're bringing all these different forms together. We're writing equations based on graphs. Not too bad. So let's decide what form we want to use in this case. So I have a graph. Do I have the vertex? I don't have the vertex. Do I have y-intercepts? Yes, I do. So I'm going to use the factored form or intercept form. A times x minus p. I'm going to use the p first this time. X minus q. All right, so in this case, I have y equals a times, and what's the p and what is the q? So x minus, the first intercept I see is at -3, 0. So it's going to be x minus a -3. The second x-intercept I see is at 5, 0. So I'm going to have a 5 there. Let's simplify. Y equals a times x plus 3, x minus 5. Okay, now we have to find an a value, so I have to use another point that aren't the intercepts. So here I have it, 3, -3. -3 is equal to, and then a times, then I have to use the x value is +3, +3. I should use red instead of orange. I always try to use the same colors. 3 plus 3, 3 minus 5. So again, -3 is equal to a times 6 times -2. So -3 equals 6 times -2 is -12 times a. And I divide, and so a will equal 1/4, or 3/12, or 0.25. So then my equation in factored or intercept form is a equals 0.25 times x plus 3, x minus 5. Now to change that back into standard form, I just need to multiply that all together. So if I multiply that all together, I'm going to get something different, 0.25, and this is going to be x squared minus 2x, and minus 15. Multiply that all out, 0.25 x squared minus 0.5x minus, and that's going to be 1/4 of 15, which is going to be, I think, 3.75. And there is the standard form. And I got that all just by multiplying it out. So I have standard form here. I have factored form or intercept form. Okay, and now to finally go to vertex form, I have to find the vertex of this equation. Now it's easiest if you can just see what the vertex is, but I can't. I can't really tell what the vertex is, so I have to use my other method to find the vertex, which is to use the factors, find the x-intercepts, and find the middle. Okay, so if I find the middle between -3 and +5, I have to add them together. -3 plus 5 and divide by 2. I get, looks like 2 divided by 2. All right, and that makes 1, I believe. So x equals 1. Notice my scale is going by 2. 2, 4, 6, -2, -4, -6. So I know my vertex is at 1. To find out what the vertex actually is, I have to plug it in. So y equals 0.25. I have 1 plus 3, 1 minus 5. So I think this is actually going to work out pretty nice. 0.25 times 4 times -4. That makes 1/4 of -16, which is -4. So my vertex, the vertex is at 1, -4. So to write vertex form, pretty easy. Y equals, what's the a value? 0.25, x minus h, 1, plus k, -4. So notice I just used the h and k from the vertex to write it in the vertex form. So now you see it written 3 different ways. All 3 of these are the same parabola, except in different forms. We have vertex form on the bottom, standard form in the middle, and factored form at the top. All right, now we have a couple more exercises in the last minute here. Write the equation in vertex form whose graph opens the opposite direction. This one opens down, so that means I need to have a positive value here. And is shifted left 3 and down 5 from the equation. So if I want to go left 3, right now h is 3. H is 3. If I want to go left 3, I have to subtract 3, so h has to be 0. So I have x minus 0. And I want to go down 5, so I need, right now k is 1, so I need to go down 5, subtract 5, so k now has to be -4. So I can use any number I want. Let's use 5. So what about 5 times x squared minus 4? That will work. Let's do another example. If I want to shift this one, it opens the same direction, narrower, and shifted right 3 and down 3. To make it narrower, I need my y value or my a value to be closer to 0. All right, we'll finish this in class, I think. Have a good night.